Okay guys, let's talk about this dude first. So if you are coming in on the left side, are you a product or are you a reactant, Yandel? You are a reactant. If you know that this side is the reactants, then Vince, what's the other side? Product. Good. And that number that goes at the bottom there that is below the letters, that is called the what, Ophelio? Good. Yep, that is the subscript. Sub helps remind us that it is under the letter. What is the number that is out in front, Lyndon? Coefficient. That is the coefficient. Good. And that leaves us with which word to represent the arrow? Yields.
I'll put convert.
Yields. So this yields these products. Now, almost everybody who got to number 2 did the following. They said that density equals mass divided by volume. Density equals 15G over 30 milliliters. And then almost everybody who got done with this problem said D equals 2G over ml. What did they do wrong? What did they do wrong there? Let me hear from Kayla. What did they do wrong? They divided wrong. Good. What is 15 divided by 30 actually? Ariel? 0.5. Please be careful with that. We have a tendency, right, to divide by what's on top, or the bigger number, but make sure you always divide by this divided by that. Be really careful. Okay, so today our objective is to continue on with what we learned yesterday with the law of conservation of mass, and we're going to add on the process of balancing equations. And so what I want you to start off with today is looking at this diagram that is at the bottom, diagram A and diagram B. And I want you to talk with your neighbor about that first question. If you had to make an informed guess, which one of those two would you say follows the law of conservation of mass? And make sure you tell your neighbor why. We'll come back together in a minute and a half. You can start talking now.
Me.
Why? Which one do y'all think follows the law of conservation of mass? B. Why? They're equal. What does the law of conservation of mass say? Good. And can mass be created or destroyed? Okay, write that down. Good. Raise your hand if your group said that the answer choice should be A. Raise your hand if your group said that it should be B. Good. So now you should be telling me B and why. B because, and what statement? What did the law of conservation of mass say? There you go. There you go. So is that one's equal, right? It's just changed. It's equal. This one is destroying something. Okay, let's come back together in 3, 2, and 1. So Paula, why would B represent the law of conservation of mass? Good. What did you say, Tahidra?
I said B because they both equal.
What's equal about them?
The letters.
Good. So what do those circles with the letters in them represent? Do those represent, is this representing compounds? Is it representing elements? Is it representing atoms? Anybody think anything different? What would those circles represent? What do you think, Lyndon? I think it represents elements, compounds, or atoms. What does one of those represent? An atom. Good. Why does that, so let's talk about why that matters here. Because when you're doing these experiments, right, sometimes the compound that you put in is going to change and turn into something else on the product side, right? We've seen that in the experiments that we've done. So what doesn't change though is the amount and the number of the atoms. So the atoms will switch places with each other, but whatever is on one side needs to show up again on the other side. And so if I were to tell you that one of these terms you would call it balanced and one of these terms you would call unbalanced, I want you to say, okay, which one of those would go with which? Is model A balanced or unbalanced? And what is model B? And I want you to tell your neighbor why you picked what you picked. We'll come back together in 1 minute. What do you think, Lyndon?
You know, the air bell look like on this side, like on here, we got two, and one, two big ones. But these two are together. Them sides are greater.
Yeah, good. What about it is greater? The elements, compounds, or atoms? The atoms. It is. Good. Take about 10 more seconds. Finish up with which one's unbalanced, which one's balanced. Vanessa, is model A balanced or unbalanced? Good. That is an unbalanced one, which means that B is balanced. And Vanessa, how did you decide that that was balanced and unbalanced?
Because model B is equal.
Because what? Good. Yep. What is equal? The number of what is equal?
Atoms.
The number of atoms. Excellent. Let's take a look at this bottom one. Does this follow the law of conservation of mass or not? I'm going to do this one with you, so your eyes should be up here on the board. I have 1 magnesium. I have 2 oxygens. I have 1 magnesium and 1 oxygen. So I have 3 total atoms on this side and 2 on that side. Raise your hand if you would say that is balanced. Raise your hand if you would say that is unbalanced. Good. Why, Natalie, is that unbalanced?
Which one?
Why is this unbalanced?
This one, the first one?
Why is this unbalanced?
Because they have like the same number.
Good. Doesn't have the same numbers on both sides. The total has to be the same. Take your paper, turn it over to the back of page 1. And I want, let's hear from Ophelio. Remind us what the law of conservation of mass says.
Cannot be created or destroyed, but it can be changed.
Good, excellent. And so we're just reiterating that again, and then just adding in today that yes, they can change. The atoms can change their pattern. They can change into different types of compounds. But if it obeys the law of conservation of mass, meaning there's atoms on both sides that match up, that is a balanced equation. And if it does not obey the law of conservation of mass, that is unbalanced, meaning what we put into our reaction is not what came out. So it's an unbalanced reaction. Take about 10 seconds, not very many notes today. Turn and tell your neighbor what the difference between balanced and unbalanced is. What's the difference? What's the difference between balanced and unbalanced? Good. We're going to take a look at how we're going to do these problems. I want you guys to look with me at that first problem where it says 2AL plus 3O2. Every single time you do a balancing equation problem today and then through next week, it needs to be set up in this exact way. So please watch as I do it. I actually don't want you to take any notes. I simply want you to watch, and then afterwards there will be a time to go down and copy, okay? So I just want you to watch what I do. The first thing that I do when I set up one of these problems is I'm going to create a T-chart that represents my reactants and my product side. So I'm going to make a T like this. So that's step 1. My step 2 is to list out every element that I see on the products and on the reactant side. So I say, okay, I've got Al, and as a reminder, whenever L is like that, when it's lowercase, that is not an I, right? If this was an I, if it was a separate element, it would look like this. So just be really careful. So I've got one AL, I've got an O over here, I have an AL, and I have an O. So I'm listing all of my elements. That's step 2. List the elements. Step 3 then is to go and count the number of atoms. So as a reminder, when we have a coefficient out front, we have to multiply. So I have 2Al, and that means I have how many oxygens then? I have 2 as a subscript, but I have a coefficient of 3. So how many atoms of oxygen do I have? I have 6. On this side, I have a coefficient of 2 and a subscript of 2 for Al. So I have 4, and I have how many atoms of oxygen? 6. So on this side, then, so that's step 3, is I find the atom, and I need now to add them all up. So I have a total of 8 atoms on this side, and I have a total of 10 atoms on this side. Raise your hand if you would say that that is balanced. Raise your hand if you would say that that is unbalanced. Good. Why is that unbalanced, Jocelyn?
The numbers don't equal to each other.
Good. And what do those numbers represent?
The total number of atoms.
Good. It is unbalanced, so it does not obey logo. Now I want you to go and copy this down now that you've seen the process. Once you're done copying down this model, I want you to try the now you try problem.